Hello, I'm Anna Mackay, and in this video we're looking at sample size. So what do we know about a confidence interval? We know that it is a 95% confidence interval and that is 1.96 standard deviations either side of the mean. So the width of that, with the mean being centered, is the distance from the middle to the end and to the left, 1.96 standard deviations. So what is that in total? The distance from the middle out to, say, the right-hand side is this amount here, this 1.96, lots of the standard deviation over the square root of n. So therefore, the width in total would be 2 lots of that. I'll write that out. And as this topic suggests, we're interested in determining the sample size. So if the width of your confidence interval was to change, how would that affect how big your sample needs to be? Currently, the subject here is W for width. Let's rearrange it to get N as the formula so that we can determine our sample size. So I'm going to essentially switch root N and W. And then to make N the subject, I'm going to square both sides. So that's our formula for determining the sample size for N. So that's for a 95% confidence interval where sigma is the population standard deviation and W is the width of that confidence interval. Looking at these examples of confidence intervals here, looking at our first one, as we increase N, let's have a look at, so up to 50, 100, 200, let's have a look at the left endpoint. It is 9.1 approximately, and then it goes to 9.4, 9.6. So you could say that that left endpoint is increasing, getting closer into mu, and the upper endpoint, 10.8, 10.5, 10.39, it's decreasing, so again that's coming in. So the width of that confidence interval is shrinking as what happens? As the size of N increases. So as you can see here, by increasing the sample size, we produce confidence intervals of shorter width. How is that valuable? Essentially, the more people you survey or the more apples that you take for your sample, the narrower the width of the confidence interval is going to be, which means that you've got a tighter range for making predictions or about your mu, your population mean. However, the amount of time and effort, money and energy that it might take to do a sample of 200 in comparison to a sample of 20 would be quite a bit more work. So sometimes you have to weigh that up. Do you want a confidence interval with a shorter width, which will involve a bigger sample, or you have only got the time and the resources to do a smaller sample, but therefore have a wider confidence interval? Some examples here. Have your calculator ready to determine a 95% confidence interval for the mean heights of adults. A random sample of 100 is taken. Whenever I see information like that, I like to write it out straight away. The sample mean is 150. And what's the symbol that we use for that? We're going to use X bar because it's a sample mean, not mu, because that would be a population mean. And the standard deviation sigma is 20. So to do a confidence interval, we go to our graphics calculators. We're going to select menu 2 for statistics, and we're doing an interval for a confidence interval for Z, and it's one sample. And here are our options here that we need to input. Confidence level is 95. It's asking us for sigma. I've got it written off to the right here of 20. Our X bar is 150 and our N is 100. And see what that calculates to be. 146.08 and 153.92. I'll write that on the other screen. So we were asked to determine the 95% confidence interval for the mean heights of adults, and I'm going 146.1 and 153.9. In the middle we put mu, not X bar, and you can have less than or equal to. Next, we're asked to state the width of that interval in part A. So the width of that is the distance between the lower and the upper endpoints. So essentially you take the big number and subtract the small number, and the width we get is 7.8 centimeters for that confidence interval. Now we're asked to find the sample size required to reduce the width of that 95% confidence interval to 5. So what's the width currently? 7.8, and we need to reduce that width. So our sample size will need to increase. So we substitute that into our formula here. 2 times by 1.96 lots of the standard deviation, which was 20, divided by the width, which is 5, squaring all of that gives you an answer of 245.86. Now, what units is that? That's people. So how many people we actually need to survey? Approximately 246. Now, we're going to talk about rounding in our next example. Oh, I suppose I should put people here. Next, example 2. Y is a random variable with unknown mu, but the standard deviation is 11. We're asked to find the sample size required to achieve an accuracy of mu plus or minus 2 at the 95% level. So you might think, oh, I don't have mu, is that a problem? Well, let's have a look at the formula here. The variables that you need to know are sigma, we know that is 11, and the width. Let's have a think about that. If you've got mu and you want the accuracy within 2 either side, so a plus 2 or a subtract 2, what's your width in total? It's not 2, is it? It's 4. So that's what our width is going to be. So let's substitute that in. And the answer for that is 116.21. So if this is our answer here, the question is, to achieve the width of plus or minus 2, do we take it as 116 or 117? Do we round up or do we round down? Now, instinctively, from all your years of rounding, you'd want to round that down because the decimal is less than 5. Here, often in sample size, we're faced with counter rounding, and now I'm going to justify to you why. The way to check this is to produce a confidence interval using these 2 different sample sizes, and let's see what the width that you get is, and are they different at all? We want the width of the confidence interval that we end up with to be what? It has to be accurate to within plus or minus 2, which means a maximum width of 4. So it can't go over 4. So let's have a look which one will produce us the answer that we desire. So to our graphics calculators. Okay, so we're going to go into stat mode. We're doing an interval, we're doing a Z interval and 1 sample. So you get to confidence level 95. Our standard deviation is 11. What was our mu? We didn't have one, did we? No. Okay, well, let's have a think about that. We'll come back. Our N, we're going to try 116. Now, here's my suggestion. My maths teacher at school always said, when you get stuck with a question, any question, try and put in a real number. The question told us that we're going to have our mean and we're going to have a width of 2 either side of that. So does it really matter what our mean is? If our mean is 0, we need the width to be 2 either side of that. If our mean was 100, we need our width to be 2 either side of that. So it actually doesn't matter. The sample size is still going to produce the same width. So play with a number. Pick a nice number. So I'm going to choose 100. And let's see what happens. So we put it in for a sample size of 116 and we get a confidence interval of 97.998. I've written that off to the right hand side here, and the upper is 102.002. So that's what we get for 116. Let's do 117 while we're here, just changing one number, and we get what I've got written off to the right, 98.007 and 101.993. And we're interested in the width between those. So I'm going to my run mode now, and I'm going to subtract those 2 numbers within each interval and see what I get. So 102.002 subtract 97.998, that's the width of our confidence interval, and we get 4.004. Let's do the second one. Sample size of 117, 101.993, subtract 98.007, we get 3.986. And if you remember the question, we wanted a width plus or minus 2, which meant a maximum width of 4. So the first one was a sample size of 116, the second one was 117. Let's go back to the question. And the question I posed to you was, do we round up or down? Our mathematical answer was 116.21, so it was closer to 116, but 116 will not give us the width that we require. It's too big. And so this is where in sample size you're often faced with counter rounding. So you pretty much always round up in sample size. So the final answer for this is find the sample size. The sample size is 117. Join me in the next video for 9D.3 testing claims about mu. Subscribe to the channel. Thank you.